Go to O, get the Word doc out of it. Boy, howdy. All right. So we already have the idea of this graph paper, you know. It's called the Cartesian Plane, where you have x values going off to the right and you have y values going up. And then if your x values went negative, they'd go off to the left, and if your y values went negative, they'd go down.
You uploaded the wrong Word document. The one you uploaded was the flowchart for summation and factorial.
Ah, for Pete's sake. Thank you. Allow me to fix that. But it's a really good flowchart. There we go. Refresh, grab again, it'll be the right one. So when we did the smiley face, we'd written a circle or a draw a circle function that moved the turtle, lifted the pin, put the pin back down, and drew a circle. And we're going to use something very similar in this one. And I'm going to give you the code so we don't have to recreate it from scratch. But then we're going to modify it to do that scaling, the multiplying or dividing, doing the shifting, the addition subtraction. So our final goal will be to draw this cute bear using our draw circle function.
That's not cute, that's terrifying.
Oh, he's so sweet.
Especially whenever you start looking at the chart.
Yeah. Some people make his eyes red or whatever, and scare him up a little bit. So, what is the XY position of the following point? Well, it's at 10 on the X, and its Y is 30. So let's put 10, 30. And if you can't edit it, then there's a little menu option up here where you can make it editable. What's that called? Anybody have to click it? Did it say it was edit, read only? Okay. So, what is the XY coordinate and the radius of the origin of the circle? Now, our draw circle programs, due to the way that the turtle library is designed, we don't measure our circles from the middle point, which it makes sense, but along an edge point, because that's how the turtle draws it. So we're going to say that the origin of this is at 40, 20, with a radius, let's eyeball it, maybe 15? I think it's 15. Especially since the whole thing goes from 10 to 40, which is a distance of 30, and you divide that by 2.
I would agree with you.
15. Pardon?
No math.
Okay, no math. We'll try not to do too much. So let's tackle the bear. But first we need to do a simplified version, or we will do a simplified version. These will be the pieces we tackle first, so we probably won't even do all of those. So, in class we will try to get this drawn with the graph superimposed. So let's just do 3 pieces of the bear first. Which 3 are we going to do? We're going to do 2 ears and a head. We need to figure out their points. So ear 1, kind of like 24, 25. I'm going to say 24. You don't have to agree. You can put his ear somewhere else. And 51, about. What does the radius of that ear look like?
42.
Looks like it's like 10.
10. Yeah, I could go with 10. Yeah. So hopefully the second ear is the same size if we're going to make him a symmetrical bear. And his Y value ought to be about the same because it's at the same height, but it starts at about 76, I think. 76.51. And so the head, about 30. Maybe a little less than 30, but 30 is going to be good enough, I think. So it's got to have a radius of 30. What position is it at? It's at 70 and 30. I typed in 40. You're right. I need to fix that. So it's at 70, 30 with a radius of 30. Alrighty. So here's some code. Rather than make us all type it in and get typos and take up 15 minutes of our class, we're just going to copy it. So what does the code do? Wait until I paste it to start talking about it. So I'm going to go into idle. I'm going to create a new file. Just going to call it bear. New file. Don't save it in the Python subdirectories. Instead, save it in your own work directory. bear.py. Alright, so all I did is cut and paste it. And I'm going to be a good programmer and put comments at the top. I'm going to put my name, the date, turtle program for drawing a bear. Okay, so this works about the same way that our program that drew the smiley face did. We import the turtle, of course. We set its width, we set its speed. We have a relocate function, which lifts the pen and then goes to a specific X position and then goes to a specific Y position and then puts the pen back down. And it always sets the heading of the pen, the direction it's going, to 90 degrees, which in turtle land is due north. That way we're pretty reliably sure that no matter what's gone on before or after we call relocate, we know what direction it's pointing. Then there's a circle function. It takes several arguments, so it has several parameters defined. It takes an X position, a Y, and a radius, and a color. So to go to that position, it'll set the color, it'll begin a fill, it'll draw a circle, and it'll end a fill. And then one more function just for fun, a crosshairs function that goes to the middle of the screen and draws something. So down here we see crosshairs, draws a crosshairs of a certain size, 400 by 400, and then it draws a circle at 10, 50 with a radius of 50. Let's see. All right, there we go. All well and good. A blue circle is not really part of Monsieur Teddy Bear, so I'm going to comment that out for now. I'm sorry. Okay.
What's the command you put in to keep it from automatically closing?
If we want, yeah.
Because I'm running PyCharm, and PyCharm will draw it,
Well,
and then it closes.
And then closes it automatically. Okay, let's see how to fix that. There's two ways of fixing it, but so what we're going to do is we're going to modify it so that it sits there looping, waiting until the window is closed before it exits. And the reason for that is if you're using PyCharm, the better editor, then it doesn't wait for you to close. So we need to add 2 lines to our code. We're going to add this. WN is equal to turtle.screen, and then we're going to add WN.main loop at the bottom. So let's do that. Go to our code, and right above or right beneath the T is equal to turtle.turtle, add this. WN, short for window, is equal to turtle.screen, but with a capital S. And then at the very bottom, tack this on. I'm going to move it down to the bottom, so don't put it here. I'm just typing it here, and I'm going to cut it. WN.main loop. That's going to go at the bottom. Alright, so now the drawing should hang out until we actually close the window. That better?
Yeah.
Cool deal. I should add that to it. Since we're cutting and pasting, we can make the code as long as we want to. Okay, so we're going to have to add some circles to it to draw the bear. We know the X and the Y positions and the radiuses. So let's tack on 3 circles that will draw that. So where it says your circles go here, above that main loop, call circle 24, 51, 10, tan. Then the next one, $76, 51, 10, tan. And lastly, this 70, 30, 30, 10. And I could put comments. That would be ear 1, ear 2, and the head. And I commented out the light blue circle. Alrighty. Well and good, but he's awfully tiny. Looked good on the flowchart on the page here, but that's because this is drawn to a smaller scale than what we want to see on the screen. It's kind of like that, you know. We don't want that. We want a nice big one that fills up most of the screen. So we need to shift the coordinates to get it into the center. I mean, we don't have to, but we'd like for him to be right smack dab in the center of the screen. And we'd like for him to be larger. Right now he's in the upper quadrant, so we're going to want to subtract some values from it to get it to be in the center. And we're going to need to multiply the values by some factor in order to get it to be larger. So to shift, shifting is modifying the coordinates in such a way as to move the drawing to a different position on the screen. In the diagram below, we want to shift the green circle so that its position is that of the pink circle. So we have this circle here, but we wish it was down here. So right now it's at 50, 30. We want to move it so that it's at 10, 0. So I'm just going to take the difference between those values, 40 and 30. If I had anything else and I shifted it by the same factor, you know, it would move along with the circle. Scaling. We talked about scaling. That's like multiplying and dividing. The green area represents the graph shown on the prior page. So we have a small shape. But we want to zoom out, changing the scale of what is displayed to more closely resemble the pixels on the screen. We've got a lot of pixels on the screen. So we're going to take this line here, but we want to blow it up so that it's larger. So it's going to change from being a small shape to a large shape. So let's see. I guess I have sized this so that it's centered on the screen. If it's not centered on the screen, the calculation of the ratio would be considerably more difficult. But it is. So B2's X position is 40. Yeah. B2's X position is 40. That's the new position. That's the new size that we wanted. B1's X position is 20. So to calculate our scaling ratio, our factor that we want to multiply by, we just take 40 and divide it by 20. And we get 20.
No, we get 2.
No, we get 2. What am I doing? That'd be huge. Yeah, we don't want to do that. Okay. So it looks like I conveniently missed a page in the document. So let me add a note to myself here. Professor is confused and left a page out. Add it, by gum. Okay, that's just a note to myself. Anyways, so we need to modify it, our program, to do some scaling and shifting. But we need to decide by how much. So I'm going to go back to where we were. And I'd like for him to be centered, like for this position to be at 0, 0. So to do that, I'm going to need to move it over 40 pixels. You see that? 10, 20, 30, 40 on the X. And I'm going to need to move it down 30 pixels. So we're going to modify the program to have a shift factor to do that. And kind of eyeballing it, we've decided 40, 30 would work. So I'm going to go up to the circle program and make a few changes. I'm putting some extra lines here so that I have room. I'm going to say the shift X value is 40. And the shift Y value is 30. It would be if I was going to subtract them. I'm going to make them negative just like you suggest. Let's make them negative 40 and negative 30 so that we can add them rather than subtract them. So now that everywhere we have an X and a Y, we want to shift it by those values. So X, we're changing this line here. X plus shift X, Y plus shift Y. That should get it down into the center of the screen. Let's try it out. All right. Now let's add a scale. I don't know, I'm going to blow it up by a factor of 2. Alrighty, now I wish I'd made a change. You see where we added X plus shift X? Remove that. See where we added the Y is equal to shift Y? Remove that. Why? Because we're going to calculate those X's and the Y's. So let's do X is equal to X plus shift X. Y is equal to Y plus shift Y. it'll be pretty easy for you to catch up, Victoria, because we did a big copy and paste of code from the newest Dropbox. And then let's multiply those values by the scale. You know, you could scale it differently on X and Y. Like if you wanted to squish everything, you could do that, but we want to maintain what's known as the aspect ratio, you know. So X equals X times the scale. Y is equal to Y times the scale. Now there's actually one more change we're going to need to make, but I'm going to leave it like that and let you puzzle out what is broken about it. Yep. Okay. So, he's not looking too good. And so what's wrong is that we've moved the X and the Y, but we have another distance involved as well, which is the radius. So we're going to do radius equals radius times scale. I never can figure out what means I use to decide when to put spaces and whatnot, so I went back and modified it. Alright, there we go. But we can do better than that. I'm going to make them larger. I'm going to change the scale to 20. That was a bad choice. Alrighty, I'm going to lower that a bit. I'm going to try 5. Yeah, I like 5. You could make it 4, make it 6, something like that.
Hold on.
I'm going to leave mine at 5. You can tweak yours a little bit if you want. Okay. So these are the changes we made to the draw circle function right there. We added those lines of code to it.
If you're gonna go back and draw a circle, like let's say you draw another circle at the end of those 3, you would have to go back to the original coordinates.
Yeah, you'd want to go
Because
back to
it's
your
already
original graph paper.
compensating for the -40 and the -30 on the X and Y coordinate.
We don't need to compensate. We would just use the same graph paper, draw the same shape, because the scaling is being handled in that function. So we don't need to modify anything. All right. So let's draw a few more pieces of the bear. Drawn his ears. So, I don't know, his nose looks pretty easy. I think I'll add his nose. A nose at 48, 27, something like that. Okay, and the radius looks like it's going from, like it's a radius of 7 maybe, no 8, yeah, okay. So I'm going to go add some more circles. The nose at 48, 27 with a radius of 8. And mine had a black nose. Go ahead and do some more, finish drawing his face. At least take a good stab at it, if you can. Might be easier if you just had pen and pencil and you wrote the coordinates down while you were looking at it on the, the screen or whatever. So here we have a place where stuff is overlapping. If I did his inner ear at the bottom of our list, it would actually be on top of the head. Which would be okay. It just wouldn't be the shape that we have on the screen. So, you could decide whether you wanted to move the inner ear so that it was above, before the circle, the larger circle, or whether it was after it.
So how'd you say you got it to hide?
You would move it to below the head. Excuse me. The line above the head. Right. So that one looks to me like it's about at 2251 radius 8. Now the brown that the Turtle Library uses is really pretty nasty looking, so I may go look at our turtle colors for a better color. Got those confused. Yeah, that's a pretty nasty brown. So, yeah. So you notice that since I put the inner ears down at the bottom of my list, they occlude, they cover up part of the face, so I'm going to cut them and paste them and move them above the drawing of the head. And I'm going to pick a different color. So, I think there's one called Sienna, which looked pretty good. can't.
Go for one of the purple ones.
Pardon me?
I said go for one of the purple colors.
Yeah, we could do that. We can make him a Grateful Dead bear, psychedelic colors. Yeah. Grateful Dead teddy bear. Or maybe that's just black and white. Yeah, see,
Oh my lord.
he's all colorful. All right, so instead of brown, I'm going to try coral 4.
Can you do that for a second? I don't have all that type of.
Yeah, I'll leave that here. Let me test it. Still forgot to move it, but that's a better brown than it was. So I'm going to cut those inner ears, poor thing, paste them above the head. Alright, and you certainly do not have to wait for me to piecemeal these together. You may be done, or at least much farther along than I am. So the eyeballs, the whites of the eyes. That's beginning to look creepy. Maybe the addition of the blue pupils will help. Also, the nose doesn't have to be black, does it? You can always just copy one of the circle lines and paste it and then change the values. Save yourself some typing.
You know, we could use this to design the new Five Nights at Freddy's game.
Yeah. So that looks like it's at 36. 36. This one is about at 52, 36, 4. Alright, I want to wander around and see how y'all are doing now. good enough. I think I've got just about the whole thing except for the little O of a mouth. Oh, and by the way, it was cool. Some of y'all looked up how to use the circle function to draw an arc, a semicircle, and you use that on your smiley face. I was really impressed with those who did that. And lastly, the mouth at 4414. Good enough. It looks like I didn't quite choose the same radiuses, maybe a partial radius of 7.5 on something, would have been nice, and 3.5, whatever. But that's close enough, I think. And yours will probably look different if you weren't copying my precise values. If you did, that's okay. A little bit better. Specifically, we're going to talk about parallel lists, which I may have mentioned, but we're going to mention it more. Parallel list is a programming term for something that, if you've ever used an Excel spreadsheet, you already understand intuitively, which is the idea of columns. You could have somebody's student ID, you could have somebody's first name, you could have their last name, their birth date or their age or something like that. And then so student ID 123 is named Bob Roberts, you're 20. And then student ID 456 might be Beth Bethany, she's 21, and so on. So what makes a parallel list? It's two or more lists of the same length where they are all thematically united by something. The something in this case being the index number. This is at column number 2. So everything on column number 2 has to do with Bob Roberts. This is all column 3. Why am I saying column? This is row 2. Everything on row 2 has to do with Bob Roberts. Everything on row 3 has to do with Beth Bethany. Row 4, different student, Sue Smith, like that. Okay, so everybody on, or all the columns, all the entries on row 4 have to do with the same. Now, our lists, begin with index value 0. So it'd be more like that. If we were going to make these lists, we might choose shorter names. We might want to call that list ID. Do that up here. Might want to call that one F name, or just first. This one last name, and an age. Okay, so those would be good list values. Now I'm going to go back to idle and make a new file so that I can play with that idea. Okay, so I need 4 lists. ID is equal to, and I'm going to put 3 items in it. 1, 2, 3, 4, 5, 6, and 3, 4, 5. Apparently they're not sorted. F name is equal to and I got to put these in quotes. Bob, comma, Beth, comma, Sue. And then the last name. Roberts Way. Yeah, Roberts Bethany Smith. And then lastly, their ages. So if we just print out each list separately, it's not going to make much sense. It'd be like looking at one single column in Excel. Bob, Beth, Sue. Roberts, Bethany Smith. 20, 21, 35. You know, great. What if it's, 100 items long because we have 100 different students? You wouldn't want to print out 100 different ID numbers in a row, followed by 100, different first names in a row. Instead, you want to print them out just like we see here. We want to print out everything that's of element 0. Index 0, and then we want to print out everything, every item in every list with index 1. Everything of index 2. So since we have a list counting here, since we have a number counting there that we can use as our index, a for loop, a for range loop might not be nice. So for I for index, in range, we're starting at 0, so we don't actually have to fill that in. Remember that if you put a first number there with a comma, that's where it defaults. I mean, that's where it goes to the beginning. But if you don't put 1, it defaults at 0, so that's good. And we want to go to the length of one of the arrays. It doesn't matter which one. I'm using the term array. Array is a different term for a list, used in other programming languages. So I'm going to get the length of the ID list. They're all the same length. That's one of the conditions of having parallel lists, is you have multiple lists of the same length. Right now, each one of our lists is 3 long. Why did I not just put 3 there? Because if we went and added more data to the array, then it would no longer be 3. Okay, so we want to print out their first name, no, the ID, followed by a tab, followed by the first name, followed by a tab, the last name, whoops, don't put that in quotes, only the tab should be in quotes, last name, followed by a tab, and then finally their age. Alright, apparently I chose a pre-existing word as a variable name because ID is purpleized, but I don't think that's going to hurt us. I'm going to save this as plist for parallel list. Let's see if that works. Hopefully, it'll look somewhat like our spreadsheet. That's not looking real good. What did I do wrong? Oh! Give you brownie points if you know what I did wrong. If I was going to print just one element of the ID list, would I print ID? Right, I need the index value, so I'm going to use square braces and put I after each variable name.
Oh, there's another thing you did wrong.
No.
2 of them literally the first same name and same last name.
I know that. Yeah, that was intentionally stupid. Yeah.
Beth is short for Elizabeth, in which that wouldn't be the same thing. Still.
Yeah. Okay. Yeah, we could make these names a little bit better. Yeah, Elizabeth Bethany sounds better. Okay, now the tab's slightly messed up because, just because, you can't trust tabs. I should have chosen a longer name than Smith. Do I care that much? Not really.
The tab at the end of the H or what?
Pardon me?
How does it work? Why is it off?
Tabs are like every 8 spaces.
Gotcha.
So 1, 2, 3, 4, 5, 6, 7, 8, something like that. And then this tab, I'm not quite sure. Yeah, since this is 7 long, followed by a space, then it was already at this position, so when it hit tab, it jumped over here. But this one, when it hit tab, it just jumped to there. So I should have made these names shorter than 7 characters, or I should have made Smith also 7 characters long, if I wanted it to look good. Or maybe I should have printed the age first. I think I'll do that. I'm going to just move the age counter to right after the ID. So I'm taking age, and that comma that's in front of it, and I'm moving it to here. I'm also going to have to move the tab. I'm going to monkey with this a little bit. It's okay to put things on their own line like this if it's inside something with parentheses. So I'm just doing that to make it kind of easier to eyeball. And it would also be nice if we had column headers, So I'm going to put a print statement up here that does much the same thing as this. All I'm going to do is copy all this and then paste my print statement. But I'm going to replace the variable names with, strings like that. That's the ID. That's the age. That's the first name. And that's the last name. Okay. Now we got a nice little chart, and if we wanted to, we could print, dash lines over them all. So let's write some code that will add to this list. Spacing it out like that as I did, we can't get the whole thing on the screen. Yeah, we actually have the whole thing on the screen except for the comments. So if we're going to add to the list, we're going to need 4 pieces of information. Why? Because we have 4 lists. IDs, first names, last names, and age. So we'll have to ask them for the student's ID, for their first name, for their last name, and then their age. And then we will have to append those things to the list. So we'll do ID.append, and age.append, and first name.append, last name.append.
Is there a way for you to put, like, let's say you input all the things and then you pull the whole thing in and then you just append in? Like to where you already have it in a row format? And then
Well, we could let them type in the whole thing and then hit enter. So, followed by an ID, followed by an age, followed by a first name, followed by last name. And then we could use split or something like that to get it into variables. But we're still going to have to append to each list separately. There's no way to...
there's no way to append the whole row if you made each one a...
Right, because they are parallel lists. we're going to have to be adding on to ID, F name, last name, and age, and there's no one command that would tack things onto all 4 of those.
So even if you made like each, like let's say you had A equal the first name, B equal the last name, ID equals, well, obviously it's always ID first, and then added it to the, like you input A on the,
Right, that's pretty much what we're going to be doing. We're going to be inputting 4 different pieces of information, which we could call A, B, C, D, or whatever, and then we're going to call ID append A, F name append B.
I just wanted to see if there was any.
Yeah, there's no easier way, unfortunately. We could let them type in all of it on one line and then use a split function to break it up, but that'd be about the only improvement we could make. So, let's do that. I'm just going to pick really dummy variable names, A, B, C, and D. I ought to pick better names, but I'm just going to go with this. Input, student, ID, question mark. And I'm not going to bother convert, I guess I better convert it to a number. ID is actually a number, integers, and so is age. So I'm going to monkey with this a little bit. A is equal to int A. So B is equal to input their age. It's also an int. Now the first name and the last name are not ints, so we don't have to convert those. I regret how I spaced that out, so I'm going to put the tabs on the same line as the variable above them.
You dropped the comma.
Thank you. You don't have to make that change, but if you're typing along and you haven't gotten to that point yet, you might appreciate being able to see all the code on the screen. Okay. So, let's ask for the first name and the last name. Input first name. No reason to convert that to an int. It's not a number. Input last name. Now we need to append to each list. ID.append parentheses A. Age.append parentheses B. It'd be cooler to put this stuff in a loop, you know. We may change it to do that so that they can add as many students as they want to.
Would it affect how the variables?
It'd be okay to use the same variables if it was in a loop because they just get overwritten each time. Maybe I didn't answer your question.
The other ones stay in there? Like the ones that done previously, would they stay?
Well, they'll be added to the list, but if you do something like this, A is equal, whoopsie, A is equal to 3, and then later on you did A is equal to 4, that's gone. It's not added to it, you know, it's just erased. So that's going to be okay.
But if it's added onto it already, it stays in there?
It'll be into our list and it'll be saved, yeah, which is what we want. Okay. So, age.append, nope. ID was our first list. ID.append A. Age.append B. Fname.append C. And then lname.append D. There's a much better way of formatting data than what we used here. We may go back and fix that so that it wouldn't matter, you know, if something was 7 characters long or 8 characters long or 3 characters long. But we'll live with that for now. I would like to print that value out as well, so I'm going to kind of do the cardinal sin of copying and pasting code. I'm going to take my print statement there my for loop and just paste it there, because I just want to see what my data looks like after I've added that stuff. I may wind up deleting it, but I copied my print statement. Dadgummit, I should also print my headers. I'm not going to bother. Okay, so student ID 2000. Age 99. This is an old student. His name is Seth Roberts. He's the great-grandfather of Bob Roberts. Okay. So by adding one value to each list, we have created an effective, new person. Is this the way databases work? Not really. Databases do a more complex idea, which is that you create a single structure that contains all of that information, all 4 pieces of information, and then that is saved to it. And we could do that. We could make a list of 4 items, and then we could append that list to a new list. Then you have a list of lists. But I don't want to get too weird, so I'm going to just leave it where it is. Alrighty, are we good so far, or anybody need syntax help? I sure would like to not have to use that print statement like that. So let's move that into a function. And it's going to look ugly because the function is going to be right in the middle of our code, but go down above your first print statement there, and let's do def print underscore student, like that, colon, and then just tab those guys underneath it. Now I can just call print student when I want to see that information. And anybody want to take a stab at guessing why I put print student there rather than up at the top of the code? If you move it to the top of the code and run it, you'll see an error. Yeah, if we move this code up to here, these lists aren't defined yet. So that might actually work, but I don't think it will. I'm going to try it, just as an experiment. I'm going to cut this code, paste it here, give it a shot, see if it actually works. Lo and behold, it did work. Okay, I like that. I'd rather have my function up at the very top. This time it worked. Okay, so that's the current state of my program, is I have a function here, and I called print student in order to invoke it, and I'm going to do the same thing underneath all those appends. I'm going to call print student again. It would also be neat if all of this stuff, print student, appends, if all of that was in its own function, so that we could append a new student just with a single call. So let's do that as well. Let's do def Let's do that right above the first input line. Def space input underscore student, colon, and then we need to tab over all of this stuff. The fastest way of tabbing is just to hold shift down arrow to highlight all those lines, and then hit the tab key. And then cut that and move it to the top of the code as well. Alright, I know that when we're cutting and pasting and tabbing and stuff like that, that's about the time when the wheels start breaking. It's hard to follow, so I will do a walk around and make sure that we got it all working. And so between my two calls to print student, I need input underscore student. This should actually be called students, huh? Because it's actually a list. But I'm going to leave it there. Can't quite get it all on one page.
You still have the for loop at the bottom.
No, I deleted that print and just replaced it with a call to print student. So yeah, this is the very bottom of my code. This is all that we have at the bottom, and then we have two functions defined up here. Input statement and print. Input student and print student. Let them enter multiple students. So we're going to need a loop. And so I'm going to use a while true loop. Why am I going to do that? So I can let them break out of it. Nah. Let's do this right. So we need a variable. I'm not going to use while true. We need a variable that will let them specify that they want to add a new student. Maybe call it repeat. So repeat is equal to y colon. Nope, no colon. Don't know where that came from. And then while repeat equals y, like that, colon. I don't see why we need that last print statement. Tab those two guys, the print student and the input student, or append student if you called it that. But then let's ask if they wish to repeat. Repeat is equal to input, add another, y/n. And then let's convert that to an uppercase letter so that even if they type in a lowercase, it'll work. Repeat is equal to repeat.upper might do it. Just a little bit of error handling there. Okay, it would have been neat if it printed it out after that. So I guess I shouldn't have removed that print student call. I'm going to move this call to print student to underneath the input student. So I swap those. Alright, that seems to be working, and I've covered up the code with that. So this is our loop. We call input student, we get all of our information, and it gets appended to the student, to the lists, all four lists, and then we print out our entire list. Then we ask them, do you wish to add another? And we convert that to uppercase so that even if they type lowercase, it'll still work. We could have also done repeat equals equals y or repeat equals equals lowercase y. That would have worked as well. Now, unless we were going to get fancy and do something like ask for the student ID, but if it says, you know, if that student ID already exists in the list, then don't allow them to, you know, put a new one in. We could get all sorts of fancy, but I don't want to make this impossible to follow. I'm hoping at this point it's still possible to follow. So I'm going to add some comments down here at the bottom. Parallel lists equals 2 or more lists of the same length. Where the data linked by the index numbers. Just like columns in Excel linked by row numbers. Example, for lists, ID, age, first name, F name, last name. To add a new student, we gather the 4 new pieces of information and call .append on each list. So ID.append A, whatever was stored in A, age.append B, whatever was stored in B, fname.append C, lastname.append D. Anything else we need to say about parallel lists? All right. Wikipedia always has fun things to say. In computing a group of parallel arrays, also known as a structure of arrays, or SOA, is a form of implicit data structure that uses multiple arrays to represent a singular array of records. It keeps a separate homogeneous data array for... Okay. We're just going to close that. I hope that makes sense. So, for example, I might ask you to do an assignment. Write a program that keeps track of grocery inventory, things like hate to ask for UPC code, not grocery inventory, clothing inventory. We have things like the size of the item, where you have the quantity of the item in inventory, you have the color, and then you have the description, you know, or what it is. What's a better name of that? You know, it's a shirt as opposed to pants as opposed to socks.
Clothing type.
Category? I'm just going to go with name.
Equipment slot? I don't know.
I'm just, I'm going to leave it at name. I'm not thinking of a good one. So,
Brand or something?
yeah, brand would be a good one to add, but I'm not going to.
In the actual store, they separate it by department.
Okay.
Is that quality or quantity?
Let's call it quantity. which you might abbreviate QTY if you want. Okay, example, you might have a small 30 red shirt. You might have a large, it's very rare, you only have one of them, black sock. Okay, so that'd be the size, that'd be the quantity, that'd be the color, and that'd be the name. And so on. Okay. So we will track 4 pieces of information for each inventory item. So that makes sense. Write a program that allows the user to keep track of inventory Now I wish I'd put quantity first. You know, you could say 1 red black sock. I think I'm going to do that. Print the inventory afterwards. So write a program that allows the user to input data for an item, 1 large black sock, and append it to the appropriate list and print the inventory. Loop until the user no longer wishes to repeat. So it's going to be pretty similar to our program, right? So what are you going to have to do first? You're going to have to define your lists. So define your lists, all 4 of them. But they're going to be empty lists unless you want to pre-initialize it with data. We pre-initialized a silly term. How could you do something before you? Anyways, we initialized our lists with data. If we didn't want to do that, it would look like this. We could have just done that. Just done that. Just done that, and just done that. So quantity is equal to an empty list. Size is equal to an empty list. Color is equal to an empty list, and a name is equal to an empty list. That's hopefully enough information. If you need extra help, please ask me. I have office hours after this, and I usually hang out in this room for up to 30 minutes or more after the end of class. So tuck that away for safekeeping. Alrighty. Please do not start working on that while we're continuing our lecture. Let's go back and see if there's more information on lists that we want to copy inside the, or not copy, from the web page that we want to learn from our textbook. So we skipped down to lists. Looks like we skipped a few things. We may have to go back here and look. But we know what a fruitful function is. A fruitful function is something that returns a value. You count the number of items in a list. You add all the values, of a series. You calculate the product of three numbers. You calculate the interest based on, certain variables. Iteration. Those are loops. We've talked about two different kinds of loops, while loops and for loops. If you break that down, we've talked about two different kinds of for loops. One, which is a for in range, and then another that's for in list, So iteration, while loops and for loops, lopos, loops, and for loops. For x in range, no, I like I for index number. And then for value in list. Those are our two types of for loops. When you're inside of a loop, you can use a break statement to exit early. The most common use for that I can think of is if you just write something like this. While true, input, or data is equal to input a value or -1 to exit. I forgot the word input. And then convert that to an int. Data is equal to int, int. No, we don't even have to do that. Let's just do this. If data is equal to a -1, I put quotes around it because it's a string until we convert it. Then break. Like that. Else you could use the data. That's one way to write a loop. And we could have written our data loop like that, but we didn't. Instead, what we did is we asked them whether they wish to repeat. So repeat is equal to y. This is the different kind of loop. While repeat is equal to y. We ask for the input. Data is equal to input. Give me some data. And then we use the data. And then we ask them if they wish to repeat. Repeat is equal to continue, y/n, something like that. Again, I forgot the word input in front of that. There we go. So inside a loop, you can use a break statement to exit early. This can be used in a data entry loop, as shown below. Or you can avoid using the break statement by asking the user if they wish to continue, as shown below. So what's the advantage of doing it this way? Input value or -1 to exit. If you're just going to ask the user to type in, 100 numbers in a row, It'd be kinder to let them type in numbers and then have a special way of getting out, so that they could just type 100, enter, 3, enter, 4, enter, 7, enter, -1. Rather than type 100, enter, y, because I want to continue. 300, y, 4, y, you know. They would have to type twice as many things if we did it this way. However, for our inventory, for our student records, for our parallel list, it seemed to make sense to do it like this to me. Because you were entering a bunch of data already, it's not, many more questions to ask them if they wish to repeat.
The only thing is your while statement, your rank has to be something that they wouldn't want to enter normally for data.
Right. So you might want to do input value or Q to exit, or quit, something like that, something that you're pretty sure. Okay, so in this case, that -1, or the word quit now, is what's known as a sentinel value. A sentinel value is a special value that has no meaning to the series of data that you're entering. And so it can be used as a flag to allow you to exit. Because if -1 really was a valid value for our data, then that'd be really bad. The program would, stop processing because the user needed to type in a -1 as the value. Like if you're a really mean teacher and you can score -1 for tests, you did not only make a 0, you made a -1, that would be a valid value, and so using it as our exit condition would be bad. So the first example, where you do, enter data or quit to exit, quit is known as a sentinel value. Is a piece of data that has no meaning compared to the data you're entering. Data being collected. So -1 for test scores might work, but 0 as a sentinel value would not, because a student might legitimately make a 0 on a test score. So looping works great with lists. So you have a list of numbers. L is equal to 1, 2, 4, 8, 16, 32, and you want to print those numbers out. For value in L, print the value. We talked about two kinds of for lists. What was the other kind besides the for value list? The for range list. Yeah, so for I in range, the length of L, print the L list at position I, at index value I. So we're going to call this one the for value list, or loop, for value loop. And we're going to use this, call this one the for range loop. The slides, the web page does not quite use those terms. Some languages call this a for each loop. For each in L, they actually have a keyword, for each in L or whatever, a different way of specifying it. All right, so I think we covered pretty much all that we need to know about iteration. The idea of summing a list, let's sum those numbers together. If you're going to sum a list, the first thing you need to do is to declare an accumulator, a total, and then you can loop through it. For every value in L, you add on to that total. Like that. For every value in L, add that on. Then if you want to calculate the average, it's just equal to the total divided by the length of the list. So that's calculating the sum and the average. Now this language happens to have a sum function. So you could just do this. Total is equal to sum of the list. Average is equal to the total divided by the length of the list. If I ask you to write your own sum function, your own looping code, your own adding code, I'd rather you do this. But really, once you're a pro programmer, there's no reason to write this code if you've already got this one. So this is the short way to write the sum loop. Just take advantage of the sum function. In here. So the break statement we've talked about. Here we have a list of numbers, and the programmer decided that they want to not print out the number if it's odd. And as a matter of fact, not only do they want to not print out the number if it's odd, they want to break out of the loop so that no numbers after it are printed. So what they did is, if I modulus 2 is equal to 1, if the number is odd, then immediately exit the loop. So it would print a 12, because 12 is not odd. It would print 16, because that is not odd. But it would not print 17, and then would break the loop. So the only thing that this would print would be 12 and 16.
Did you write it so that it would print all the even numbers?
Yeah, you would just...
Like breaking out of the loop? It's just an example to show you how to break out.
Right.
Okay.
What I would do is I would say if modulus 2 equals 0, if the number is even, then print I. And I wouldn't put a break in there at all. The continue statement is similar to the break loop. As a matter of fact, this does exactly what we were talking about. But instead of bailing out of the loop, it just starts it again. Just goes back to the top. So if modulus is equal to 1, that means it's an odd number, then continue. In other words, don't print it. And so this would print out all the even numbers. Is 12 modulus equal to 1? No.
24 next instead of going to the beginning of the list?
Right, right. I don't use continue too much. I use break a lot more. Now you can make a list that has lists embedded in it, which is pretty unique to this language, so I'm not going to talk too much about it. But here they've made a list of students. The first item in the list is John, and he's got his own list of classes. And then Vusi's got his own list of classes, or hers. I do not know if that's... Jess has got their own list of classes, and so on. And I'm not going to talk too much about that. Okay. And an algorithm. They give us an algorithm for calculating square roots. I really don't feel like going over that. But they give us the algorithm, which is the steps that are followed in order to calculate a square root of a number. Because if you're not lucky enough to have a function that returns a square root for you, then you do it, the hard way. You roll your own. You write your own function that would calculate the square root. So an algorithm is a mechanical process for solving a category of problems. Kind of a weird. It's a list of steps that you follow in order to solve a problem. You know, you can have a cake algorithm for baking a cake. You know, it's just a series of steps. So an algorithm is a step-by-step process for solving a category of problems. The body is a series of statements inside the loop or the function. So you can have bodies inside of bodies because you can have, you know, a loop inside of a function. The breakpoint, no, I'm not going to talk about that. Bump, I never use that term. A programmer slang, synonym for increment. I never say that. Bump I. No. The continuous statement. Continuous statement causes a remainder of the loop to be skipped. Goes back to the top. A counter is something that's used to count something. Usually initialized to 0 and incremented.
Up on forums. On forum posts.
Yeah, yeah. That's about the only time I would use, yeah, the term bump. Decrement means decrease by 1. Increment means increase by 1. Encapsulate means to divide a large complex problem into components. We did that in our student program. We had a print function, and then we had, you know, an input and append function. So we encapsulated it. Why did we do that? So that when we were looking at the code, it was easier to follow. So we wrote a loop that was really easy to understand. You input the statement, you input the student, you print the student. That way we don't have 20 lines of code for inputting and 20 lines of code for printing right there inside the while loop, making it harder to read. And that way, every time we wanted to call the print, we wanted to print the data, we could just call it with a single phrase, with a single word. So that's called encapsulating. Encapsulating is putting code into functions, breaking the problem up into pieces, and then putting them into functions. Now, when I ask you to do this, create the clothing inventory, I don't care if you put it into functions or not. I think you ought to, but I don't care. It's up to you. However you want to solve the problem is fine. Similarly, our bear. I did not want to have to do all of this stuff every time I wanted to draw a circle. That'd be a real drag if we had to repeat all that code for every circle. You know, this thing took like 12 or 13 circles to draw. I would not want to have to cut and paste this code 13 different times. Instead, it's just a function, so that we can call it over and over and over with different values. I want to draw one circle, I call the circle function that I wrote. So the drawing of the circle has been encapsulated in a function. And it uses some other functions. We put some of the code into a relocate function. Now that code could have been put right here inside this function. It did not have to be its own function. But if we were going to draw something else other than circles, you know, if we wanted to be able to draw, you know, semicircles or squares or something like that, having relocate in its own little block would be useful. Because it's 5 statements of code, and it's nice to be able to just call it with a single statement like that. Here's another function. We had our crosshairs function. That way we could draw crosshairs all over it. The poor bear would be marked with crosshairs. He'd really be worried. But we could do that. We can print more crosshairs on there if we wanted to. None of these are fruitful functions because they don't need to return anything. You're just relocating. You're not calculating anything. You're just drawing a circle. You're not calculating the area of the circle. You're just drawing crosshairs. You know, what could you possibly return from that kind of function? So a lot of functions don't have return values. But some do. If they're going to calculate something, they want to calculate the area of a circle or the sum of the series of numbers, that kind of thing. Whoops. The escape sequence. We haven't been using very many escape sequences. The only one we've been using so far is tab. That's a backslash followed by a letter or some other symbol. What it means is, I don't want you to print this backslash. I want you to use that as a special command to change the behavior of the printing. \T would print out a tab. Another very common one, in fact more common than tab, is \n, which means new line. So if you wanted to, /n/t are known as escape sequences. Escape because it's escaping out of the ordinary mode. Weird term, but
And those have to be in quotation marks?
yes, they do. So /n is new line, like hitting return or enter. /t is equal to tab. There are others. This is a weird one. /double-quote. That prints out a quote. And that sounds counterintuitive. But what if you wanted to print this? My name is quote Slim. How the heck would you print that if you didn't have that escape sequence? Print my name is, if you did this, that's going to be a syntax error, right?
Yep.
Because it's going to think that this is all one string, and then it's not going to know what in the world to do with the rest of this. So we would need to preface these like that.
Even if you put another quotation mark at the end of...
You are right. That would be, thank you very much. We need one more of those.
But you could mix, you wouldn't look exactly the same, but you could mix the single quotes with the double quotes.
Exactly. You can, if you want to, since single quotes work, you could do this. My name is Slim, and not have to worry about those escape sequences. You could use the apostrophes. But some languages do not let you do that. An awful lot of languages force you to use double quotes to mean strings, and if you use single quote, it means it's only a single character, like that. So I veer away from using single quotes in my print statements, just out of habit. C, C++, Java, a lot of languages are like that. As you might guess, there's also that one, which means print out an apostrophe, which again you don't have to do if you've defined your print statement with double quotes, but if you used with single quotes, then you would need to. Okay, let's Google up Pythonic escape sequences and see if there are any other cool ones. In olden days, there was one to beep. So you could write a for loop, for x is equal to 1 to 1 million, and then make it beep. And your computer would start beeping, you walk away from it, and people around you would go crazy. Alright, I forgot that one, \. Single quote, double quote, ASCII bell. Let's see if that works. I want to see if /a makes our computer make a sound. So I'm going to go up here and I'm going to start a new Python shell. I want to print a \a. Okay, that wasn't real impressive. Kind of neat. You want to print out a little circle? Do that. ASCII backspace. You could print out a word and a backspace over it. And that might look real impressive back in the olden days when things printed on the screen really slowly. But nowadays it would be instantaneous. Form feed. That would kick out an entire page if you set it to a printer. Return. In some systems, a carriage return is different than a line feed. Carriage return sends it back to the very beginning of the line, but it doesn't actually go to the next one. So /r just went back to the beginning of the line. We don't have to worry about that. A vertical tab, that's a crazy idea. I don't know what a vertical tab is. I think we've covered all the useful ones except I forgot the \. So I'm going to go tag that one onto the notes. Why is that important? Because what if I did this? What if I wanted to print out a file name? what would that print? It would not print what we wanted. It would print C colon, but then what is a backslash T?
Tab.
That's a tab, so it would tab over some. And then we'll print E and P, and then what's a backslash N? That's probably not what we wanted it to print. So you use the backslash escape sequence like that in order to get it to print out single backslashes. So you have to escape the escape. That looks like the... No, never mind. That's quite enough. If you want to specify the ASCII value of the characters, apparently you can use backslash X. If we go back to our ASCII chart, let's see, and we want to write out bad. Bad in ASCII is a 42 hex, followed by a 41 hex, followed by a 44. 42, 41, 44. Let's see if we can get that to actually work. So I'm going to go back to my shell and print out backslash X 42, backslash X 41, backslash X 44. Awesome. Okay, let's experiment. Backslash X 1000, backslash X 1001, backslash X 1002. Neat. Not what I was expecting at all. So apparently it took that. X10 was equal to that funny cross, X10 was equal to that funny cross, and X10. So it was not allowing me to type in more than 2 digits. So I'm going to change that to X10. Oh, that's right. I'm in the shell, so you can't just go up and modify it. X10, X11, X12. Neat. So what is 10 in decimal? It's no ones plus 1/16. So it's 16. I want to go back to my ASCII chart and see what that kind of meant in the old days. The 16 used to be a delete or data link escape. None of these matter anymore. Weird things. Timber. Retrociso. This thing, I believe, had to have been written in Spanish or, well, whatever they speak in Argentina. All right, that's enough about that. There should be a way of printing out what are known as Unicode characters as well. I believe I've mentioned that since the ASCII chart only allows you to 127 or 255 different characters, that's not nearly enough to encode, you know, all the languages on the planet. And so they have Unicode, which has ASCII as the first 127 characters of it, or 256 characters of it, but then it's got, you know, thousands more. Okay, so Unicode starts with a /U. Let's just goof around. Print \U 1000, \U 1001, \U 1002. I believe that the emoji can be triggered by a Unicode character. Oh, neat. I think that crashed my program. Well, it took it a while, but it finally came back. Okay, so forget Unicode. We won't be printing, you know, Russian or Klingon or Elvish, so we don't need those extra characters. to initialize a variable to give it like a value of 0 or whatever. It gives a variable its first value. In Python, variables don't exist until they're assigned a value. So sometimes you need to initialize it. Why is that? So that if we're adding up all the numbers in a range, for value in range, we wanted to go all the numbers from 0 to 99. We wanted to add them, and then we did total plus equals x. Well, that's great and all that, but we don't have a value for total to kick it off to begin with. This would be an error because, if it was the only thing in the program, if total hadn't been defined previously, because total does not exist at this point. Can I type? It needs to be assigned an initial value, which is known as initializing. So we would put total is equal to 0 before the for loop. Now, initialize is kind of a little bit of a funny concept because, the first time you assign a value, technically that's an initialization. Like if you want to do the conversion ratio for Celsius to Fahrenheit, it's 1.8. So ratio is equal to 1.8. Yeah, you are so-called initializing ratio to 1.8, but you're never going to change its value. So initialize kind of implies that it's going to be a changing value. But technically, it's just the first time you set the variable. We know what a loop is. A loop is so-called the construct that allows us to repeatedly execute a statement, whatever. That's a lot of writing in order to explain a concept that we understand. I'm not going to ask you to define a loop, but a loop is a way to repeat statements in a code until a terminating condition is satisfied. An iteration is each time the loop repeats. The loop variable, that's a variable used as part of the terminating condition of the loop. So when we did while repeat is equal to y, the loop variable is that repeat. Holy moly, a trichotomy. Trichotomy, giving any real numbers a and b, exactly one of the following relationships hold. A is less than b, a is greater than b, or a is equal to b. Thus, when you establish the two... Okay, I don't think there's any more we need to talk about in the iterations chapter. Let's go and look at lists. We're going to be done here in just a moment. What is a list? It's an ordered collection of values. The elements that make up the list are called, or the values that make up a list are called its elements. We will use the term element or item interchangeably, apparently. I try to stick with using the word element. A list is similar to a string, which is an ordered collection of characters. You define your list like that. Square braces, if you just want an empty list, you don't put anything between the square braces. To access it, you use its index number. All lists start at 0, and they go up to the length of the list minus 1. So if the list is 10, you can go from 0 to 9. What's the lowest index number we could have in that list? 0. If we get lower, it starts doing something special. What's the highest index value we can do? It would be 2. Or the length of the list minus 1. What happens if you do minus 1? If we did list minus 1, what would that print out? starts counting from the back. That would be Sally. And then so on. That'd be -2 and -3. So 2 ways of printing the last item. Either list followed by the length of the list -1. That would get us the last value. Not hard coding 2, because what if we added data to the list? It would no longer just be 3 items long. Or you can do the list -1. Not all languages support this concept, or very few do. In fact, Python's the only one I've ever seen where you can use -1 to blip to the end of the list. So it's worthwhile to keep this in mind, this first method. I think we have gone about far enough. Let's make a Dropbox for today's work. So there will actually be 2 homework assignments based on this. One will be more fun than the other, probably. Well, would help if it had shown up there. Why you're not there? Okay, we've already drawn a bear. I want you to use the same code that we drew a bear to draw that shape. So yeah. Just write a program that'll draw the circle. So you can just take your bear program, delete all the circles for drawing the bear, and instead draw the turtle. I don't care how you color it. Notice I didn't put any scales or anything on here. You know, there's no axis numbers, so you can define, you know, if that's 0, 0 there, or if that's 0, 0 there, or whatever. It's up to you. You'll figure it out. Okay, so in scaling and shifting, we did draw a bear program. So go ahead and upload bear.py into Dropbox O. And then we did the student ID program, the parallel list program, LMNO, so that'll be P. Coincidence. So P was plist.py, which is the parallel lists for students. Please upload py.list or plist.py into there. And then our 2 homework assignments will be assignments 13 and 14. One is the clothing inventory, and then one is the turtle. All right, gang, once you get O and P uploaded, then you're good. We're done for today. We can hang out here and talk more. Otherwise, I'll see you all Wednesday.